the instance type in settings. Okay, that I'll show you in this hands-on.
Hello everyone, so this is our course Introduction to AWS Certified SysOps Administrator course. Okay, this is AWS Certified SysOps Administrator course, and this is the introduction video of it. Let us see some key points of this course, that what we are going to do in this course. So this AWS SysOps Administrator course is designed to equip you with the knowledge and hands-on experience required to efficiently operate and maintain systems on the AWS platform. From deploying applications to ensuring high availability and security, this course covers a comprehensive range of topics essential for anyone aspiring to become a proficient AWS SysOps administrator. This course is ideal for system administrators, IT professionals, and anyone looking to enhance their skills in managing AWS environments. Whether you are new to AWS or seeking to deepen your expertise, the SysOps Administrator course provides a well rounded curriculum to meet your needs. While there are no strict prerequisites, a basic understanding of cloud computing concepts and familiarity with AWS services will be beneficial. Participants with experience in system administration will find the course content particularly relevant. The only thing you should have is an AWS account and nothing at all.
So this is our EC2 instance service. Whenever you will go to your Amazon dashboard, it will look like this, and then you have to access your services here. You can search for the services, like if you have recently visited any of the services, it will be visible here, and here are all services available, and you can search EC2 from here. Like if you have to search, then you can search EC2, and here it is, EC2 virtual servers in the cloud, and you have to select it. Just click on it, you will be redirected to the EC2 dashboard, and then we have to launch an instance of EC2. Okay, so let's get started. Just click on this launch instance first, and then your instance will be launched on your location. Okay, now what you have to do, you have to enter your instance name first. So for example, any meaningful name you can give. Suppose I am giving it my first instance. Okay, first instance. In this, you have to select your AMI. AMI means Amazon Machine Image. This Amazon Machine Image is a template that contains the software configuration basically. Then just click on any of this. Suppose I have to select Amazon Linux, and from here you can select any of the AMIs. If you have to go free tier, you can select any free tier eligible. Okay, if you have to pay anything, if you have to work according to your requirement, then you can select any of the AMIs here. Okay, next is this instance type. You can select any of the instance. Suppose if you have a small work, then you can choose t2.micro, or a newer version where t2.micro is not available. t3.micro is there, but here we will be charged if we are using t3.micro. Just see, let me show you. Yep, this t3.micro here is not free, so we will not go for it. We'll just choose t2.micro, and then if you have created a key pair already, then it's okay, but first of all you have to create a new pair, and in this you have to enter your pair name. Suppose my key. Okay, this is my key pair name dot pem. I'll go with default settings only. I'll create this pair. It is downloaded here. Okay, so it is downloaded, and then what I have to do, I have to just keep the settings default. Let me tell you one more thing. You can configure your storage, and if you are using free tier, then free tier eligible. Here it is written that in free tier eligible, customers can get up to 30 GB of EBS general purpose SSD or magnetic storage. Okay, so that's all. You just have to select the number of instances. Okay, so I am creating just one instance, so I will keep this number as one. Here is my information for the instance, whatever I'm creating. T2.micro firewall security group, new security group. Its storage is 1 volume. That means 8 gigabytes. And yep, I'll just launch this instance. So my instance is getting ready. It is being launched. You can see this success message here. That this means that my instance is already created. Now what can I do? I can just check the launch log. It is initializing requests, creating security groups. Okay, so my instance is already created. Let's go to the dashboard where I can see my instance. And yes, this is my instance. This is my first instance. Instance ID is here. Instance state is running. Type is t2.micro. Status check is initializing. Alarm status, no alarms. Availability zone is here, and everything I got. And wait, yeah, when I just select this instance, I can work on into this instance if I want. Okay, so this was my instance creation. I can just connect from my instance, connect using EC2 instance connect, and I can connect it. Like suppose, just look here, I have connected to my instance and I'm into my instance. Now I can work whatever I want. I can write codes and snippets here. So that's all for instance connection. And yep, I have connected to my Amazon Linux, and whatever I'll be writing would be performed here. It is as same as your Linux machine that is installed in your system, in your local system. This is very similar to it. We will check that how we can change the EC2 instance type. Okay, so you can change the EC2 instance type if your instance is EBS backed up. And for this you have to do, like, first of all you have to stop your instance, whatever instance it is, or if it is running you have to stop that instance. Then you have to refresh it, and then it will show you that you can change the instance type in settings. Okay, that I'll show you in this hands-on. So let us start by doing so. First of all, I'll just give you an idea that how we can change the EC2 instance and why should we change the instance according to our need. Suppose we need some more memory to our file. So how can we give that? We can give that by changing the instance type. Let us start by changing this, and let us start by having one example for this. Okay, so first of all I'll check the memory that is available in my t2.micro instance type, and then I'll change this to some other instance type, and then we will check the memory. We will compare that. So first of all, let us connect to this instance EC2 user. Okay, let me connect to it. As you can see that connection is established here. Now I will write some example, okay, to show you what is the available memory in t2.micro for me. Echo hello. We will write echo hello hello.txt. We will make a file named hello.txt. Enter ls. Okay, so hello.txt is there. We will check whether this hello is there in our hello.txt or not. So cat command, using cat command we can do so. Okay, so hello is there in our hello.txt. Now we will check the memory. Okay, free minus. So this is our memory. 949 total, used 153, free 578, available 656. Okay, now what I'll do, I'll just change the instance type, and as I said, the steps were, I'll not just clear it, I'll use it for comparing. I'll click on this EC2 connects. Okay, this is my running instance. I'll just stop this instance right now. Stop instance. Yeah, stop. As you can see, this instance is already stopped here. EC2 connects is already stopped. Now what I can do, I can just change its instance type by just clicking here, instance, and in this action we will go to instance setting. We'll click here, and yeah, this is the option, change instance type. If your instance is running, then this option is disabled, like this, change nitro enclaves. This is disabled option. So if your instance will be running, this will also be disabled. But if your instance is stopped, as I have stopped it, this will be accessible. I'll just change this instance type to like T2 small. Suppose I want to change it to T2 small, and I'll apply this. So here my instance is already changed instance type is t2 dot small, as you can say, see here. And now what I'll do, I'll just start this instance, and then I'll write the same commands. I'll just check the file that I have created. Let me connect to it. This is, yep. So this is my instance is running here. I am just connecting to it, and I'll just check the file size. Okay. Previously it was 949 total, and I'll just check for hello.txt. Let us. Okay, so I have connected to my instance. I'll write ls. So hello.txt is there. Cat space hello.txt. As I have changed instance type, so this is hello is there now. Free minus n. Look, this is 1956. This memory has been increased as I have changed the instance type. So if required, as per your requirement, you can change the instance type. So this was how we can change the instance. And please don't forget to stop this instance or change this instance type first. Okay, I'll just change this instance type because you want to be in your, if you want to be in your free tier limit, so you can just change, or either it will charge you. Okay, let's talk about enhanced networking now. So it is another way for us to get better networking performance for our EC2 instances. And so we have the type EC2 enhanced networking SRIOV. Okay, it gives us higher bandwidth and higher PPS, packets per second, which is with a lower latency. And this is something that can come in the exam. Also, we have two options for this. First one is Elastic Network Adapter ENA, which supports till 100 gigabits per second. And option 2 is, or choice 2 is Intel 8259 VF to 10 Gbps. Okay, this is legacy. So this EC2 enhanced networking, especially the ENA adapter, works for the newer generations, or you can say the latest generations of EC2 instances, as we will see in the hands-on practical. Okay. Also, then we have elastic fiber adapter, fabric adapter, you can say, which is an improved ENA dedicated for HPC. Okay, it only works on Linux. Great for internode communication, tightly coupled workloads, as we know, because they live in the same cluster. So we have a lot of internal node communication, and those node communications are tightly coupled. Okay, then there is MPI. This MPI is basically, like, suppose when they are living in the same cluster, then they are going to get better network performance. Okay, while talking to each other. So when talking to one another, this is going to leverage a standard, and this standard is called MPI standard, which is message passing interface. Okay, and the idea is that elastic fabric adapter is having a higher performance because our EC2 instances are talking with one another, and so it knows that it will bypass the underlying Linux OS to provide low latency, reliable transport. So this is all we have now for theory. Let's move on to hands-on, and we will see what are the drivers for like older generation and newer generation. In older generation, we will see T2 dot micro, and in newer generation, we will be seeing, suppose, T3 dot micro. We will be making an instance, and then we will be doing some hands-on. So let's move on to hands-on. So this is my instance. This is T2 dot micro. I have already made it. So I'll just start it for now. Okay, I'll just start it. Until then, I'll make another instance of T3 dot micro. Okay, newer version instance type. So let us name this like // only. Let us not name it anything. AMI. Okay, Amazon Linux 2 AMI I'll be selecting, which is also free tier eligible to me. Instance type will be T2 dot micro. It is now, it will be T3 dot micro. T3, just look, T3 dot micro will not be free because T2 dot micro is free to me, so it is chargeable. So if you are making an instance of T3 dot micro or any not free eligible instance, so make sure you stop it to make it some cost effective. Okay, now I'll select a key pair, which is my key. Then I'll just keep all the settings as default. I'll launch this instance now. Okay, so this instance is successfully initiated now. Now I'll be just checking, I'll be refreshing this, and here it is, my instance, it is running right now. And let us connect to t2.micro first. Okay, let us connect to t2.micro instance. Okay, this is the username, EC2 user. I'm good with it, I'm okay with it. Okay, so now we have already connected our t2.micro instance. Now we are going to write some basic commands to check, like mod info space ena, and this will just show us the information, and this is installed now. Now we'll be writing another command to check the drivers, which are the drivers in this, and whether it is a latest driver, like it is ena or not. We will check it right now. So we will just see eth tool minus h0 minus I. Okay, I forgot that, minus I, and then h0. Just click enter. You can see driver is our VIF. Okay, this is an older version. Now in t3.micro we will check whether it is a newer version or not. So let us connect to t3.micro instance. This is an instance type, and let us connect to it. Now you can see I am already connected into my t3.micro instance, which is a newer version of instance. And yep, let us write mod info space ena. And as I have connected Amazon Linux 2, so this is same version 2.10.0. And let us now write another command, which was our ethtool dash I eth0, and let us see, this driver is our ena. This is nothing but ena, which is new version, new driver. So yep, we have enhanced our networking. So this is how we can enhance our networking, by making newer type of instances. See, we will do theory this time. So placement groups are basically a bit more advanced, and we want to use them once we want to have control over our EC2 instances. Okay, so sometimes when we want control over EC2 instances, placement strategy, so we use these placement groups. Okay, now that type of strategy is basically called placement group. Suppose if we want control over our EC2 instance placement strategy, then that type of strategy is defined as placement groups. Then we can create a placement group, and then we mention one of the strategies for a group. And what are the strategies? So we don't get direct interaction, because we don't get direct interaction with hardware, AWS hardware, because it is cloud, AWS is cloud, so we don't get direct interaction with hardware of AWS. But we let AWS know that how we would like our EC2 instance to be placed compared to one another. Cluster. So first is cluster. Clusters instances are basically all the, like EC2 instances are placed at a single or in a single cluster. Clusters instances into low latency group in a single availability zone. Okay, single AZ you can say. Next is spread. Spreads instances across underlying hardware, maximum 7 instances per group per availability zone can be there, and this is used in critical application. Okay, we will see details in a second. And then third comes partition. Partitions are basically spreads instances across many different partitions. We just spread our instances in different partitions within an availability zone, and it can scale to hundreds of EC2 instances per group. In a group we can place many of instances, EC2 instances, like Hadoop, Cassandra, and Kafka do. Next comes placements groups cluster. Okay, now let's start. This is the first one, basically placements groups cluster. Let's start. So in this placement groups cluster, all the EC2 instances are interconnected. Okay, you can see all the EC2 instances are connected to each other in a same rack. They are placed and in the same availability zone. So now this placement group cluster is this low latency and high throughput. it gives you high throughput. So in a network where low latency and high throughput is required, we can use placement groups like this. Okay, what are its pros? Pros is great network, 10 Gbps bandwidth between instances are supported here. What are cons? So if the rack fails, suppose, because all the EC2 instances are placed in the same rack, so if the rack fails, all the instances fails simultaneously. Okay, at the same time all the instances will fail and we will lose our instance. Next comes use case. So big data work that needs to be completed fast, at that time placement group cluster is used. Okay, those application that needs, as I said, that needs extremely low latency and high network throughput, then at that case we can place all the EC2 instances at the same rack and in the same availability zone using this cluster. Now comes placements group spread. Okay, in this case, when we asked for a spread placement group, all the EC2 instances are going to be located on different hardware. So as you can see here, we have 3 AZ availability zones and we have 6 EC2 instances. Basically in this we have 2 only. Total is 6. We have 2 EC2 instances per partition. Okay, and now what we will see, that these are groups basically, and these are located on different hardware. Suppose first is on AP South 1A, then next is AP South 1B, next is AP South 1C. So these are all different, located at different hardwares. Suppose EC2 1 is on hardware 1, EC2 next is hardware 2, other is on hardware 3, other is on hardware 4. So what does that mean? Well, what we get is that we can span across multiple availability zones and there is a reduced risk of simultaneous failure. And why so? Because if any of my hardware suppose fails, I am pretty sure that my hardware 2 will not fail, or my hardware 3 will be there to support. Okay, and so that is the benefit from it. What is the pros and cons now? Pros can span across different availability zones. Reduce risk is simultaneous failure, as I said. EC2 instances are on different physical hardware. So when they are on different physical hardware, if one fails, then another will be working. Now, what are cons of it? So basically, it is limited to 7 instances per availability zone per placement group only. Next is use case. So application that needs to maximize high availability, we can use it there. Next is critical applications where each instances must be isolated from failure from each other. Suppose if my first instance is failed now, and if we want to separate, isolate them, so that if my first instance fails, then another instance which is located at different hardware should work properly, should not be affected. So there we can use this placement group spread. Next we can use placement groups partition. In this you can see partition. And what is this? In this partition placement group, we can have instances spread across partitions. Okay, in multiple availability zones. We can have 7 partitions per availability zone. So in this example, we have partition 1 in US East 1A, partition 2 in US East 1A, partition 3 in US East 1B. And on each partition, we could have many EC2 instances. You can see on this partition 1, we have 4 instances. In partition 2, we have 4 instances. Partition 3, we have 4 instances. We can take as many as we can. So in the first one, I have 4, second one, 4, 4, and all this. So why do we use a partition placement group? This is the question. Well, each partition represents a rack in AWS. So by having many partitions, we are making sure that our instances are distributed across many hardware racks, and so therefore they are safe from a rack failure from one another, as in we saw in cluster. As in our cluster, our EC2 instances were interconnected with each other, and if one fails, then all the system fails, all the EC2 instances fail simultaneously. But this is very different. This partition is very different from the first case. Okay. Next is up to 100 of EC2 instances could be kept, as I said. The instances in a partition do not share racks with the instances in other partitions. Next, a partition failure can strike many EC2 but won't strike other partitions. Suppose here, if in my partition 1, suppose there are 4 EC2 instances. So if one instance fails, then other instance would be affected, but the instances which are on different partition won't be affected. Other EC2 instances won't be affected by it. So this is something better. This is something advanced about this placement groups partition. EC2 instances get access to the partition information as metadata. They have images, they have metadata in that. Okay. So this was a placement group partition, and usually the use cases are going to be big data applications which are partitions aware. We have used like in our Hadoop system we use partitions or buckets. So partitions there, that static partition and dynamic partition are use cases of this placement groups partition, like SDFS, HBase, Cassandra, and Apache Kafka. So I hope now here you have got placement groups partition, and now you can understand what are all the partition groups, and I hope now you can work on it. So next we will do some hands-on on this. We will be doing some hands-on. We will be creating placement groups in AWS. So open this EC2 dashboard, and in this scroll down, and then you will find placement groups in network and security. So in network and security, placement groups are there. Just click on it, and now we will be creating placement group. While creating placement group, you have to name, suppose this is my placement group. So the first placement group was cluster, so I will name it my placement cluster. Okay, my placement cluster. I'll choose strategy, I'll be choosing cluster here, and then I can add a tag, or suppose I have created this group. So my placement cluster group will be created here. You can see this cluster, and all the instances will be shared in the same cluster. Okay, all the instances that I'll be making will be saved in the same cluster. Next, I can make another placement group, which is my placement spread. My placement spread it is. Let me name it my placement spread. Okay, then I'll choose strategy, which is spread. Spread, in this spread, the EC2 instances are spread across different hardwares. So here you can see rack, that means hardware or host. So I'll be choosing racks here. I hope you know why. And then I'll be creating group. So this is strategies spread, and then whatever instances I'll be making will be saved in different hardwares to prevent EC2 instance failure. Okay, next is I'll be creating placement partition. And in partition, I hope you have watched my previous video. So in partition, what we do, we choose number of partition. As I have mentioned in my theory in my previous video, that we can make up to 7 partition in one placement group. So I have chose the maximum number of partition, and now I'll be making this group. So this is how we can make placement group in AWS.
So hello friends, in this video we will see the shutdown behavior and termination protection in AWS instance. So first we have shutdown behavior. So whenever we make an instance, we have two options. Instance will be shut down in two ways, okay? And those two options are, first is stop, which is by default, and second is terminate. We can terminate instance by its shutdown behavior only, okay? Next is, this thing isn't applicable when we shut down from console. We will see how. Okay, we will see it on our hands-on. Next is CLI, instance initiated shutdown behavior. This is the CLI stuff, CLI command, which is very much relatable by its name only. Next is termination protection. So we can enable termination protection to prevent accidental termination of our instance. Suppose if we have 2 or 3 instances and we want to shut down another instance, we want to terminate other instance, and by mistake we terminate our useful instance. So to prevent that type of stuff, we can enable termination protection of an instance. The note is, if we have shutdown behavior is equal to terminate. Suppose if we have ticked the shutdown behavior as terminate and termination protection is enabled, then also instance can be terminated from OS from CLI by writing sudo space shutdown command. We will see how. Okay, so now let's move on to hands-on and let's check whether this is applicable or not. So here I will launch an instance first. My instance name, let us name it hyphen only, nothing else, dash dash. Amazon Linux AMI2 I'll be choosing, and then instance type is equal to t2.micro, no worries, architecture 64-bit. Key pair I'll be selecting my key. Okay, no security group, no changes in that. We will just move on to advanced detail, and here in advanced detail you can see that shutdown behavior by default it is stop, but now we will choose terminate because we want to do shutdown behavior is equal to terminate, and we want to do some hands-on on CLI. Okay, next is termination protection, and then we will be enabling this termination protection. So termination protection is enabled now, and we will just launch this instance. As you can see, my instance is in now running state. We named it dash dash. Okay, this is instance ID. Now what we will do, we will just try to terminate it because we have enabled termination protection, and we will see what is the message we are getting. So whenever we will terminate, so here is the message, termination protection enabled. So we have enabled termination protection. Now let's terminate, try to terminate it, and you will see that it is failed to terminate an instance. The instance may not be terminate. Okay, this is the message we are getting. So we have prevented our instance from being terminated accidentally. Now we will go on to CLI, and then we will check whether we can shut down it from the CLI or not, and what stuff we are getting when we are writing shutdown command, because I have set shutdown behavior is equal to terminate. So whenever I should shut down, my instance should be terminated. Okay, so let's check whether it is being terminated or not. I'll just connect it. Okay, so I'll write simple command which is sudo space shutdown, and we will check whether it is being terminated or being stopped. Okay, so as I have enabled shutdown behavior is equal to terminate, so it should be terminated. Let's check it. The system is going down for power off at this moment. Okay, let's now check whether it is being terminated or not. What is its shutdown behavior now? So we will go on this tab, instance EC2. We will check our instance ID, and instance state is running here. In a moment or two it will be terminated. Let's wait for it. Okay, now you can see instance state is here terminated. So our instance is terminated successfully when we entered this command sudo space shutdown in CLI. So this is how we can enable shutdown behavior as terminate, and we have terminated it. We have checked that if you have termination enabled, termination protection enabled, and you have instance like behavior is equal to terminate, then it will be terminated in CLI. Here we will see EC2 launch troubleshooting. Okay, so let's move. The first type of error that we can get whenever we are launching an instance is instance limit exceeded, and this error basically shows that we have reached the maximum number of vCPUs in a region. Suppose we are provided a limit of like 64 vCPUs, and we reach that vCPUs in a region, then this error might occur. Okay, like instance limits are set on a per region basis. Suppose if you are in US, so your region, whatever your region is, that will be your instance limit will be set as per your region only. For example, suppose if you are running on-demand instance types, then you will have 64 vCPUs by default. Okay, next is how to solve this error, how to resolve this error. So the solution of this error will be like, if you can launch your instance on a different region, you can do so, or you can put a request on AWS to increase your limit for the region. You can put a request simply on your AWS to increase whatever limit you want, okay, and they will increase that for you. vCPU based limits only apply to running on demand instances and spot instances that we will see in hands-on right now. Okay, so let's move on to hands-on. Let's check. So here is our EC2 dashboard. Let's see something like the first thing is how we can check whether what is our limit of vCPU. Okay, so let us check. Earlier in AWS that thing was present here below this events part, but now it is shifted to service quotas console. Okay, now it is shifted to service quotas console, and this service quotas console is a very cool service. So you would go into the Amazon Elastic Computes in this. Let's open this first, service quotas, and here on the very right side you will get manage quotas, and just click here AWS services, then type Amazon Elastic Compute Cloud. Okay, because the full form of EC2 is Elastic Compute Cloud, as you know. So just click on it and get the quotas, view quotas from here, and you will get that there are a lot of quotas as per like their alphabetical order. So let's search standard keyword now. All standard spot instance request has a 64 limit, and running on demand as well has 64 limits. But now here you can see that I have 32 because I have applied account level quota value, right? Let's check it. Here I can also increase, like if I reach this 32 vCPUs, then I can just request increase at this account level. Okay, and let us see that which type of instance holds how many vCPUs. So we can check that by launching an instance in EC2. So whenever you are launching an instance in EC2, so just click on it, launch instance. Okay, and then check your instance type, and in that instance type vCPUs are given, that how many vCPUs an instance is taking. Suppose this t2.micro takes 1 vCPU. Okay, and we can compare instance types from here. Suppose I had 32 vCPUs in my limit. Okay, 32 vCPUs in my limit. So suppose if I just select this c3.8x large instance type, and the required vCPUs are 32 here. Okay, suppose I create this instance, then the limit will be reached in one instance only. So after that, if I'll request another instance, then it will show me that error. Okay, so this is one type of error that I might get, and I can resolve it by either changing my availability zone or either requesting AWS to increase my limit. Next is, let us see some more troubleshootings and some more errors right now. So let's go to theory part again. As this instance limit exceeded, we checked that how many vCPUs are present and how we can resolve this, how we can check that which instance type contain how many vCPUs. Okay, next type of troubleshooting is insufficient instance capacity. This error occurs when AWS doesn't have enough on-demand capacity in the particular availability zone where your instance is launched. And solution is, you can wait a while before requesting. You can, suppose if you are requesting continuously, then just take a break and then again you can try after some time. Next is, suppose if you are requesting for 5 instances, Okay, so rather than applying all at once, you can break down the request and request multiple instances one by one. Okay, if needed, submit a request for a different instance type too, and then you can change that instance type as per your requirement, as we have already seen that in our previous videos, that how we can change the instance type. Also, we can request the EC2 instance in a different availability zone. We can request EC2 instance to be launched in a different availability zone, so that that zone should have enough on demand capacity and we do not get this type of error. Next is instance terminates immediately. Suppose if you are creating an instance and from pending it just goes to terminated and it doesn't shows you running or stopped. So how this error can occur? You might have reached your EBS limit. EBS snapshot might be corrupted. Okay, you should check that. The root of EBS volume is encrypted and you do not have the permission to get the KMS key. Suppose the root EBS volume is encrypted and that you do not have key or permission to get the KMS key, so you cannot terminate, like launch your instance, and you cannot run. Your instance will terminate immediately. The instance store backed AMI that you use to launch the instance is missing a required part, an image.part.xx file. Next is to get the exact reason why that error is occurring, why that instance is being terminated immediately. Then you can check out the EC2 console of AWS. In that instances and in that description tag, you can note the reason which is next to the state transition reason label, and you can check that reason from there, and now you will know that what is the reason behind the termination of the instance. Okay, so I hope you got this video correctly, and now you can troubleshoot if these type of errors occurs while you are working in AWS. We will see that how we can connect to EC2 with SSH and what problems we might get when we are connecting with SSH. Okay, we will see how can we edit security groups, edit inbound rules in that. So let us move. You will get an unprotected private key file error if you don't have 400 permissions for your private key PM file on your Linux. Okay, you might get an error. Make sure you provide correct username for the OS when logging in into SSH, else you will get host key not found or permission denied or connection closed by instance port 22. Port 22 is the port at which EC2 instance runs actually. Okay, reasons for connection timed out might be your security group is not configured accurately. This might be a reason for a message connection timed out to EC2 instance whenever you are connecting via SSH. NACL, that is network access control list, it might not be configured correctly, that might show this error. Next is view the route tables for the subnet. Okay, if you are connecting your EC2 instance with SSH, just check inbound and into that route tables whether the subnet is given correctly or not. Instance might not have a public IPv4. Your instance might not have a public IPv4 address, that address which is used to connect to your instance, okay, in your region. Next is CPU load of the made instance might be high. Suppose if your CPU load is high, instance might not get connected and it might show connection timed out. Okay, it may show that result to you, so that is an error. So these may be the reasons of this type of message. So this is all possible reasons. Next is whenever you are connecting to EC2 SSH troubleshooting, then suppose if you are connecting with a permanent key, then what happens if you are not a user with correct IP address, then security group would not allow you to enter into the EC2 instance or connect to the EC2 instance. Next, whenever you connect EC2 instance with API, then what happens, then there in every region like this, you get a IP prefix. And suppose you are a user whose IPv4 is 1.2.3.4, then you are connecting with EC2 instance via API, then it will give you a one-time SSH public key which is valid for 60 seconds to connect to your security group, or you can say to connect to your EC2 instance. Okay, so let's do some hands-on on this. Let's see how can we connect with SSH. So this is our instance that we have made. We have saved our key, we have made a key .pem key and we have saved it. Okay, now what I'll be doing, I'll be just starting this instance. Okay, this instance is successfully started. Let's click on this instance ID. Now I'll be copying this public IPv4 address, which this address is given to me. Okay, public IPv4 address. Then I'll be opening my command prompt with administrator. Okay, this is my IP basically. Okay, let's paste it. Look, this is the location where I have saved my key. Okay, .pem key, my EC2 ssh.pem key. Okay, what is key? You can see that in my previous video when I made an instance, I had to made a key and I downloaded it and I have stored that key here in this location in my PC. Okay, now I'll just click enter here and you will see that I'll be connected successfully into my instance. Okay, I have to type yes and then I have permanently added. Now I can access my instance. Okay, I am connected. Now if I write echo hello, then yep, hello will be printed here successfully. You can see that. Correct? This is the message. So I am successfully logged in. Now I'll just log out from here. What I'll see now, I'll just go to the security settings. In that I'll be opening security groups and here type is SSH. Okay, I'll just edit inbound rules. In this rule there is source is custom and this is 0.0.0.0. Now what I am doing, I am just doing this my IP, which is private IP basically. Okay, this is private IP and now I am saving it. And when I have changed this inbound rule, I have edited inbound rule. Now this IP is this. Okay, still I can connect. I have changed it to private my IP, but still I can connect using the same commands. Okay, these are the commands, these are the code basically, and using the same commands I can still connect using my SSH. See, I'm successfully connected. Okay, now I'll again log out from here. Now what I'll do, I'll just do some more changes and see. But now what you will see that I have edited it to my IP. Okay, I just changed it from 0.0.0 to my IP. Now what I am doing, I'll just try to connect my instance through here from the dashboard itself. I'll be going to instance. Okay, so I'll try to connect it from here. Connect. Okay, when I try to connect to my EC2 instance, because I have changed my security group, I have edited my inbound rules. Now this shows that I cannot connect to my EC2 instance because I have edited my inbound rule. I have changed my security group, so I cannot connect to this. Okay, so to get correct IP, what I can do to get correct IP, to get my IP, I can just copy this, okay, and paste it to a new tab. When I'll paste it to a new tab, this thing will open documentation, Amazon EC2, and then user guide for Linux instance. And in this, I can just go to security group rule, and then I'll see all the AWS IP ranges. I'll open it now. Okay, and in this I'll just download this IP ranges JSON, and when I'll click on this type of page will be opened. Look, and and in this there are regions, IP prefix, service, network, border group, and I have to select my region here. Okay, I have to select my region, in which region I am. So my instance is at, you can see, instance EC2 AP Southeast 2. Okay, my location is Sydney, which is AP Southeast 2. Here is AP Southeast 2. Okay, service Amazon AP Southeast 2. What I have to do, I just have to connect now. So I'll be checking this IP prefix. I'll be just copying this IP prefix right now. Okay, and I'll be changing it to inbound rules, the inbound rules that I am having. Okay, let's go and edit inbound rule, and then paste the region's IP into that. Here is security, here is security groups. I am in editing inbound rules now. Okay, I'll be changing this to this regions IP, save rules. This is now updated successfully. What I have to do, I have to connect it again. Okay, so here you can see I have connected to my EC2 instance as I edited with my regions IP, okay, which was AP Southeast 2. I just edited this into my inbound rules security group, and now I'm connected into my EC2 instance. Okay, so I hope this video is very clear to you. And one more thing, let me tell you, if you will change this user group here, username here, while writing this command, suppose you have written this command and you are just changing the username, which is EC2 connect, okay, which is this one. Suppose I am logging out, and then what I have to do, I'll just do this. So here it is EC2 user. If you will change it from EC2 user to any other username, then also you will not be connected to your EC2 instance. So make sure you are entering correct username. So I hope this video is now clear to you, and we have covered all the things regarding SSH troubleshooting. So we will see the EC2 instances purchasing options, that what type of purchasing options are provided by EC2 instances or AWS for us. Okay, so let's move forward. First is on-demand instances. These type of instances are useful for short workload. Predictable pricing are here, and you have to pay by second. Okay, suppose you have to pay every second for your usage. Okay, next is reserved. Reserved is like you are reserving an instance for certain period of time. So here if you have a long workload and you know that you are going to work on it for 1 year or 3 years, so these type of reserved instances are better for you because they give a certain amount of discount. Next is convertible reserved instances. These types of instances are sub part of reserved instances. Basically in these type of instance, reserved instance, convertible reserved instance, they provide you some flexible instance, like you can change the instance type or instance size. We will see in a minute. Savings plan are basically, suppose you are paying some amount, you have proposed some amount, like I will pay this much amount every hour or for this time, like this duration. Suppose you have said that for 1 year I'll be paying $2 per hour to you. So according to that payment scenario, they will give you an instance, okay, and they will fix your availability zone. They will lock something for you, and you will be using that for a certain period of time. Next are spot instances. Spot instances are basically used for short workloads, and they can be lost anytime. You can lose instances anytime. They are very less reliable. So these are spot instances. Next are dedicated hosts. Suppose you are booking an entire physical server and controlling instance placement, that where you want to place your instance, so that is dedicated host. Dedicated instances are basically no other customer will share your hardware. You will have your own hardware with yourself and you will be using it. Next, let's see one by one. So first is EC2 on demand. Pay for what you use. You are paying for what thing you are using. Suppose you are using it on Linux or Windows, so billing will be per second after the first minute. In any other OS, billing will be per hour, okay, per hour based. Next is has the highest cost, but it has no upfront payment. You will be only paying for your usage only, okay. You don't have to prepay anything, okay. Everything will be like you will get a bill and you will have to pay for what you have used. Next is no long-term commitment is here. You don't have to commit that I am gonna work with you, or I am gonna book this instance for 1 year or 3 years. So there is no long-term commitment. You can leave that EC2 instance anytime because you are on demand. You are demanding that instance and you are just paying for what you are using here. Next is recommended for short-term and uninterrupted workloads. Suppose you have a shorter term and uninterrupted workload you want, okay, so you have to work on 3 months only, and then you will be paying it. Suppose for 3 months whatever you are using you will be paying for it, and you don't want any interruption, then also you can use that. You can't predict here. Suppose you can't, it is short term, but you can't predict that how application will behave. Is it gonna work in 2 weeks or 3 weeks or 1 month or 3 months? So you don't know, but yes, you have an idea that this is a short term stuff and I can work on it. So you can use EC2 on demand. No discounts are given on this. Next is reserved instances. EC2 reserved instances are basically giving you 72% discount compared to on demand instances, because you are reserving it for a long period of time, okay. You have reserved a specific instance attributes like instance type, region, tenancy and operating system. You have reserved it for a specific time, like reservation period is 1 year, so you will get some discount. If you are reserving it for 3 years, you will get more discount. Payment options, if you are not paying anything, no upfront payment, then you will get some discount. If you are doing some partial payment, then you will get a moderate discount, and if you are paying all the amount at one go, you will surely get some more discount in it. Reserved instances scope. Suppose you are reserving your instance on a region or a zonal scope, so you can reserve your capacity in any availability zone here. Recommended for steady state usage application. If your application doesn't want any interruption in that, and it doesn't wants to be lost also, so this type of stuff EC2 reserved instance can handle. Okay, you can buy and sell in the reserved instances marketplace. Suppose you have used only 2.5 years and you have reserved your instance for 3 years, so that 6 months, for that 6 months you can sell your instance in reserved instances marketplace. So you can also buy and sell, so this is also something that is more beneficial to you. Convertible reserved instance, this is another type of sub part in reserved instances. In these we have the privilege to change the EC2 instance type, instance family, OS like operating system, scope and tenancy. You can change all the things. You will surely get some lesser discount than reserved instances because you are getting these type of privilege to change your EC2 instance type at any point of time. So it will surely not give you that much discount, but yeah, it will also give you a bit of discount like 66%, which is lesser, but it is much more greater than on-demand instances. Next is EC2 savings plan. You get a discount based on long-term usage up to 72%, same as RIs, okay, reserved instances. Commit to a certain type of usage, $10 per hour for 1 or 3 years. What you are doing here, you are just committing a certain amount that you will be paying to AWS, okay, for some duration like 1 year or 3 years. In this, what you are doing, you are not giving that I want this instance basically. No, you just want to pay this much amount and you will be using whatever instance they are giving you. Usage beyond EC2 saving plan are billed at the on-demand price. Suppose you have crossed your EC2 saving plan bill, suppose you have crossed your $10 per hour. Okay, so now what? So now you will be paying at the on-demand price. Okay, because now your saving plans has been crossed and you will be paying your on-demand price. Logged to a specific instance family, it will be logged like if you have micro or T2 or T3, it will be specific. Okay, and AWS region is also fixed here like M5 in US East I. So these AWS region is also logged here whenever you are working with EC2 savings plan. It is very flexible across instance size. You can change the size at any point. Okay, you can also change the OS like Linux or Windows at any point of time. You can also change the tenancy like host or dedicated or default. You can also change that. Okay, EC2 spot instances. Now what is this? So this is the most feasible stuff because you will get a higher discount on it. You can get about 90% compared to on-demand instances, but there is some drawbacks. Let us see. Instances that you can lose at any point of time. If your maximum price is less than the current spot price, you will lose that. Now what is this? Suppose if you have set the price is your price is like $20 and you have crossed it, you have $21 or $22 used. Okay, so you have used your more than your maximum price. Your current spot price is more than your maximum price. So what now? Your instance will be lost. Okay, the most cost efficient instances in AWS, it is very useful that are resilient to failure. Okay, it is very useful for works that are resilient to failure. You can afford that failure of instance at any point. You don't have to worry. So in that use case, you can use this EC2 spot instances. Very useful for batch jobs, data analysis, image processing, any distributed workload that you are having. Next is workload with a flexible start and end time. It is not suitable for critical jobs or not for databases too. That is actually true, because if you are having a database, you want it to be stored for a longer time. Okay, so in this type of instance you are losing that, so you will not prefer that I'll be using spot instances for critical job or databases, because I might lose this instance at any point of time. So there is no point of storing anything here which is useful to me. Next is EC2 dedicated host. Now what is this? So in this, a physical server with EC2 instance capacity fully dedicated to our physical use. Okay, we will get a whole physical server with EC2 instance capacity which is very dedicated to us. Next, it allows us to address compliance requirements and use our existing server bound software license per socket per core per VM software license. Now purchasing options are very same like on demand or reserved. You can reserve or on demand here for active dedicated host. You can also place your instance at any like you have that instance placement role here, you have that power here, you have that permission here to place your instance wherever you want. Okay, the most expensive option, because you have the whole server with you, you have booked the whole server, so this is actually most expensive option. It is very useful for software that have complicated licensing model like BYOL, which is bring your own license, so you can use this physical server here. Next, it is useful also for those companies that have strong regulatory or compliance needs. Next are EC2 dedicated instances. Now instances that run on hardware that is dedicated to you only, you are not going to share it. Okay, but you can share it with changing instances in same account. Okay, may share hardware with other instances in same account. Suppose you are sharing your hardware from other instances. Okay, instances run on hardware that is dedicated to you, you cannot share it, but you can share hardware with other instances. Okay, in same account, you have your account, you will be using it, but you cannot share your hardware into another account, into any other account that is not made for you. Okay, no control over instance placement, you do not have any control over instance placement. If you will start or stop, it can move, it will move. Okay, can move hardware after stop or start button. Characteristics, here are some usage which will be asked or might be asked in exam. So EC2 dedicated host and EC2 dedicated instance basically are not same. Actually they are very different. Okay, in that you are booking a whole server, here you are just booking an hardware. Okay, you are just locking a hardware. Next is EC2 capacity reservations. In this type, you are reserving on-demand instance capacity in a specific availability zone for any duration. Suppose it is 1 year or 3 year. You have access to EC2 capacity when you need it. Okay, no time commitment is here. Okay, you can create or cancel anytime. No billing discounts are here. Combine with regional reserved instances and savings plan to benefit from billing discounts. Suppose you want some billing discount, then you can combine it with regional reserved instances and saving plans. Next, you are charged at on-demand rate, whether you are using it or not using it, whether you are running your instance or not, you will be charged because you have fixed one instance for yourself only for a certain period of time. You don't want anyone to interfere there, and you don't want any stuff to be like interfering in your work, in between your work. So that is only for you and you will be using it. Suitable for short-term uninterrupted workloads that needs to be in a specific availability zone. As I said, if you don't want any interruption, or it is short-term basically, because it is charging you on demand. So if the work is short-term, then using capacity reservation will be good. But if it is very long-term thing, then you should use reserved instances, because if you know that it is gonna take your 3 years or 1 year or 2 year, then you should use your reserved instances strategy, that pricing, because that will be more beneficial to you. But if it is a short-term thing and you want that, I want the same EC2 instance, I don't want to change availability zone to, then you can use EC2 capacity reservations. You can go with this billing option, purchasing option basically. Now summary: on demand, coming and staying in hotel whenever we like, we pay the full price of room. Suppose I am coming to a hotel whenever I am liking, whenever I have a vacation, I am just paying the full price of the room and I am staying here. Next, reserved thing, planning ahead. I have planned that I'll be going with my family after 2 months, and then I'll be just living there for 3 years in a hotel, 2 years in a hotel, or 1 year. Then I have reserved that, or then I might get a good discount. They will give me a good discount because I am just using their hotel for 1 year, so I am their regular customer. Okay. Next, saving plan. Now saving plan, suppose we have taken a hotel as an example, so we are taking this. So savings plan, paying a certain amount per hour for certain period and stay in any room type. Suppose you are paying you will be paying like $10 or $15 or $20 or $30, whatever amount, for a certain period of time, and you are okay with, suppose they are accommodating you in any room, you can stay in any room type, king, suite, sea view, any room type. So this is your saving plan, that okay, I have fixed my amount, you can check whatever room type you can give me. Next is spot instances. Spot instances is basically the hotel allows you to bid for the empty rooms and highest bidder keeps the room. But this is not safe actually. Suppose you are staying and someone bids more than you, then they will kick you out from there. So this is not a feasible option. Next is dedicated host. What is dedicated host? So this is actually like you are booking a whole and building of a hotel and you are using it. So if you are actually just acquiring the whole building of the hotel, you are booking the whole building, then it will be costly to you. It will not give you any discount, but you have that access to all the rooms. Okay, next is capacity reservations. You book a room for a period of time with full price. You don't want to stay in it, or you are staying in it. Okay, suppose you have booked a room for 2 months. So either you stay in it or not, that doesn't actually matters. So this is capacity reservations, that I have this room. Okay, whether I'm living or not, you should not ask me that. You just give me, I'll be paying price to you, and I'll be living as per my choice. Next is price comparison. Suppose I have taken the example M4.large USCs one. So in this, these are the price type and these are the price per hour. Suppose on demand is $0.10. Spot instances are basically giving you much discount than on demand, and all the instances, all other instances are giving you billing options are giving you much discounts. Okay, dedicated hosts are giving you on demand price only. Capacity reservations also give you on demand price only. All other instances type, price type, gives you much more discount. We will see spot requests, saving plan, reserved instances, dedicated host, and capacity reservations. We will talk all about all these things. Okay, let's start. So first is spot requests. So when you will open your EC2 dashboard, then in the left hand side in instances at the fourth position, there is spot requests. Okay, so what is this and how we can use it? So for the theory part, you can see my previous video which I have posted on this channel. So what are spot requests now? So basically they provide us a lot of discount, like apart from on-demand instances. When we were using on-demand instances, we had to pay more amount, but now when we will use spot requests, so these are basically some instances that can be lost if we reach our maximum price that we are giving to AWS. But this is a good thing whenever we are working on a small workload thing, or whenever we are working on a small project whose time duration is low. Okay, so let's see the pricing history first. Okay, so suppose we have chosen this instance type. Next is our data range. Data range might be, you can choose it for 1 month or 3 months. Suppose we have chosen it for 3 months. In 3 months we can also choose graph according to availability zone or instance type. With availability zone, you can see, suppose your availability zone is for AP Southeast 2A, AP Southeast 2B, or AP Southeast 2C. So this is the region which is the cheapest for us, which we can use, and we can get the most amount of saving, which is 74.92% savings. Next is how we can make this spot instance. So let's go back and see this. Okay, so you can request your spot instance here. Whenever you will request your spot instance, you can manually configure it, or you can use a launch template instead. Okay, suppose if I am here using manually configure launch parameters, so I'll be selecting an AMI. Suppose I am choosing Amazon Linux 2 AMI HVM only. I am keeping it default right now. I had made this key pair already, so I'll be using it, my key. Okay, additional request details. So this is my, if I don't use it by default, so what will happen, I'll be given an option to choose IAM fleet rule, which is request from or until. Okay, next is what is the behavior of our instance when that request expires. So I can choose it to be terminated or not terminated. Okay, so first, this is the case what we can do in additional request details. Next is target capacity. In target capacity, I can set the number of vCPUs, number of instances, or the number of memory, how much memory we are using. Suppose I want like 10 vCPUs. Okay, so I can enter here 10 vCPUs, and this is our total target capacity. If we have specified this, we can allocate part of the target capacity as on demand. But see, here it is written that we have set the target capacity, I want 10 vCPUs, so it will choose the best like 10 vCPUs from any instance. Suppose we want to maintain target capacity. Okay, so how we can maintain target capacity? So if interruption behavior if any interruption is there, target capacity, the vCPU will be terminated. We can choose it to stop or hibernate. Okay, let's keep it default right now. Let's keep it one only. Okay, we will also keep this default additional request details. Next is network. We can choose network or availability zone. You can also choose instance type requirements. Suppose you can do two things here. You can manually select your instance type. Suppose you are selecting c5.large or c1.medium, you are adding them here. Okay, you have this spot saving, spot price. You are giving this whole stuff, that how it will charge you, how AWS will charge you for all these instances. This is here, you can choose any of them. Okay, next is, suppose I want to specify instance attributes that matches our compute requirement. Suppose I just want 32 vCPUs and I'm not confirmed that which instance type I should work on. So I'll be choosing the instance attributes only, and then AWS will automatically give me a proper instance that I should work on. So this is something which is very beneficial if you don't know about instance type, which instance type should you use. Okay, next is allocation strategy. So spot allocation strategy could be done on the basis of price capacity or optimized, or just capacity optimized. In this capacity optimized, suppose if you want a higher capacity but you don't care about prices, so you can go for this capacity optimized. But if you want that we should have capacity and it should be cheapest also, so this is the best option, price capacity optimized. We can see all the strategies here. There is lowest price option also, and last one is not so. Okay, next is your feed request at a glance. This is our feed strength, which is just strong. I'm not going to launch it because it might be much costly for me, but you can see this is 77% better than on demand, because I am getting 77% savings here. Okay, but estimated hourly price will be 0.023 per hour at this target capacity, so I am not going to launch it because it will charge me. Next is, if I want to launch this spot request from the EC2 instance launch time only, I can do this that also. While I am launching an instance, there is a option in advanced details. Suppose I am launching an instance here. So here in advanced details, we have an option for like this. Wait, let me show you. Okay, here is a purchasing option. Okay, you can request spot instance from here. You can customize it. Either you want to set some maximum price or no maximum price. You can also set your request type to be one time or persistent. Suppose if you are keeping it persistent, then it will request you until the time reaches. Okay, suppose if I have selected this persistent, I would have to also select the valid to time. If I want to set some time that this spot instance should request again and again till the expiry date, so I can set this expiry date. Or if I don't want any expiry date, that it should not have any expiry date, then I'll be selecting this no request expiry date. Okay, here one time is basically it will just request for spot instance for once and it will be terminated then. Okay, you can also select the interruption behavior, as I said, terminate, stop, or hibernate. You can also hibernate, terminate, or just stop that interruption behavior. Next is capacity reservation. You can also set your capacity reservation, tenancy, RAM disk, all these things, and then you can launch your instance. So this is how we can set spot instances while we are launching an instance. Now we will see savings plan. What is the savings plan? Savings plan are basically, I have explained it in my theory, but I am just telling you this, that suppose you set a price in AWS and then you say that okay, I'll be paying this much to you, and whatever you will give me, I'll be working on it. Okay, so this is saving plans strategy. You can also purchase saving plans here. Okay, let's see this now. Here is cost management, billing and payments pages here. Now we can also purchase a saving plan. Suppose I want to purchase a saving plan, I can also choose that whether I have to choose compute saving plan, EC2 instance saving plan, or SageMaker savings plan. Compute saving plan basically applies to EC2 instance, AWS Fargate, and AWS Lambda. Here EC2 instance saving plan, as named, it will only be applied on instance, okay, within the committed EC2 family that you are choosing. Term, you can also choose term either for 1 year or 3 year. Saving plan are basically, as I said, that if you are just planning to go to a vacation and you have booked your hotels there, so you are basically, what you are doing, you are actually choosing a saving plan for yourself, okay, that at that exact moment you won't be charged more, okay. So this is a feature of saving plan which is available on AWS. Next we can see reserved instances. What are these reserved instances? So basically these reserved instances are, we can purchase our platform, we can set our platform tenancy offering class, and then we can choose a in an instance which is reserved to us only. This is basically an instance which is we will be choosing it for like 3 years or 1 year term. We will select that term. Suppose I've just searched and the best instances are here, like I have applied t3.micro. So effective rate are this, upfront price is this, hourly rate is $0.000. Okay, this payment option is here, and see, if all upfront payment I am doing, I'll be getting more discount. If I am doing no upfront payment, I'll be getting lesser discount, and if I'm doing partial upfront payment, then I'll be getting moderate discount in this. I can also choose quantity here. I can add to cart and I can view cart, and then I can purchase that reserved instance. The reserved instance is basically that type of thing that you have just chosen that you want to stay for 2 year or 3 year on a place, and you are just paying that money, and you will not be like given, your instance won't be terminated here. You have reserved your instance for that proper term, and you have set your instance type, instance family, and you have also chosen your term here basically, okay. And also offering class, standard offering class or convertible. In standard you can't change your instance type in between, but you can also choose your instance type in convertible offering class, sorry. So you can choose this. Next is dedicated host. Basically dedicated host, as I told you lastly, that a proper server will be given to you, like you have booked a whole building in a hotel, that is actually a dedicated host for you, okay. Basically what is this, you are just reserving a host, okay, physical server fully dedicated for your use, and you are just using like name tag, instance family, you are choosing that, okay, this is instance family I'll be using. Instance type, then you will give that, okay, in that instance family I'll be using this instance type which is launched on your dedicated host only. You will choose that in which availability zone your dedicated host is located, okay. So all these things you can do. You can also choose quantity from here. So this is basically dedicated host and how you can choose this dedicated host here. Next is capacity reservations. Basically this is something like you are booking a room in a hotel, and what you are doing, you are visiting there sometimes, or you are not visiting there sometimes. So if you are not visiting, then also you will have to pay for the reservation. Like suppose I have created a capacity reservation. I am creating a capacity reservation. I have this instance type which is a1.medium or a1.large. I can choose any of them. Platform is like Windows, Linux, whatever you can choose. Availability zone you can choose. Total capacity of instance you can choose. You can also choose the time at which specific time your reservation should end. Like suppose you have in a hotel, you have chosen that, okay, I am just booking this for 2 months, okay, and after 2 months from this date this capacity reservation will end. So at that specific time your capacity reservation will end, and when it ends, that instance would be no longer of your use, or it would no longer be yours, okay. You can also choose manually here, okay, that either like you are booking a room in a hotel, and you have said that okay, whenever I want to cancel it, I will cancel it. Okay, I am not selecting a date. Okay, when I need it, I would just cancel that. So this is something that capacity reservation remains active in your account until you manually cancel it. Okay, so this is one option in which you can deactivate or activate manually your capacity reservation. Okay, so this was the video of all these saving plans: spot request, reserved instances, dedicated host, and capacity reservation. We talked all about these things. We will see burstable instance. The instances like T2 and T3 are burstable instances. AWS has the concept of burstable instances. And what are these burstable instances? So burst means that overall the instance has good CPU performance. Like if you are working and if your instance is getting burst, then your CPU will have a good performance. And when does it burst? So suppose when the machine needs to process something unusual or unpredictable thing, like a spike in load, for example, so it can burst. Okay, so your instance will burst and then CPU can be very good. And why I'm saying this, because suppose there is a spike, then you know that your CPU usage will be more, so your CPU performance would be decreased. Okay, your CPU would slow down. To prevent that slowdown of CPU, your instance get burst. If the machine bursts, it uses burst credits. So according to your instance type, like in T2, if you're selecting T2.nano or T2.micro or T2.2x large, so according to your instance type, some burst credits are given to you from the AWS only, and you can use that burst credit whenever there is a load in your instance. Okay, if all the credits are gone, the CPU becomes slow. The CPU generally becomes slow. If the machine stops bursting, credits are collected over time. Suppose your machine is not bursting, so it will automatically be collected. Credits will be collected over the time. Next is burstable instances can be fabulous to counter unexpected traffic and getting the assurance or insurance that it will be handled in a right manner. Burstable instance, suppose it is very good because if you have unexpected traffic and if you have a higher workload, then it will assure you that yes, your workload would be handled in a right manner. Your CPU won't be slow down. Okay, if your instance oftenly runs low on credit, you need to shift on a different type of non-burstable instance. Because suppose if your instance is very oftenly it runs low on credit, then what? Then you should shift to different type of non-burstable instance, because your instance might not be able, that instance type in which you are in might not be able to handle that type of workload. That is why it is bursting again and again. Next, credit usage. So this is the picture of credit usage and credit balance. So here you can see that this is the time 0.0000002 by 10. So here at this time your credit usage is more because your CPU is having a load here. So your credit usage is here, but your credit balance, suppose it is around 590. Okay, suppose this is around 590. So this was 590 till this time, until this time. But when your CPU was on load and when it started using credit, here your credit balance is getting low. Okay, it's getting low. So this is a picture depicting your credit usage and credit balance relation. Next is CPU credits. So here all the information about CPU credits is given to you. T2.nano launch credits 30, vCPUs 1, CPU credits earned per hour 3, max CPU credit balance 72, vCPUs 1, baseline performance 5%. All these are instance types. Okay, and T2.2x large has the largest vCPU collection, has the highest launch credits, can earn most CPU credits per hour. It has also like you can earn CPU credit balance 1944, vCPUs are 8, and it can give you about 135% of CPU utilization. experiment run a CPU stress command to peak at 100%. Suppose after the credits are exhausted, the measured CPU utilization drops. Okay, here is the picture of CPU utilization. Here it is 100% CPU utilization. Your CPU is being utilized at the full capacity here. Now your credit balance at the same time would be dropping drastically. Okay, and when it becomes a zero, your credit is exhausted, then what? Then your CPU utilization would be slow again, low again. Your CPU will be slow here. Next is, it is possible to have an unlimited burst credit balance, but surely AWS will charge you for that. Suppose if you have exhausted your credit balance, then also your CPU performance won't be low if you are selecting unlimited burst credit balance, but they will charge you for that. If average CPU usage over a 24-hour period exceeds the baseline, then the instance is built for additional usage per virtual CPU per hour. And you have to be careful, you have to monitor again and again so that you don't go beyond your whatever budget it is for you. Here it is the picture representing CPU utilization, credit balance, and CPU surplus credit charge. And this surplus credit charge would be charged to you by AWS. So you should have this on mind. Let's do some hands-on on this. I have this running instance now. Let us see where we can have credit specification, where we can enable that unlimited or standard. So when you launch an instance, suppose I am launching an instance here, when you move down, my family should be T2. Okay, T2 or T3. So my family is here T2.micro instance family. Next I'll be moving to advanced details. Here are the advanced details. Let's look. So here you will find credit specification. Okay, and this credit specification, if you will select that like unlimited or standard, and on the basis of that your credit will be utilized. Suppose you have chosen unlimited, then if you cross your credit balance, then addition charges will be applied by AWS to you. And if you are choosing standard, then what happens? If you are choosing standard, then if your credit balance is used up, then your CPU will ultimately be slowed down, and that will be like your workload. If your workload is higher, then your CPU will not perform according to you. Next we can also see, like if I am moving back, this is my running instance. I can also monitor my CPU utilization from here, like in this monitoring. I'll click this and you can see that I have not used this instance much. I have just created it, and here is my CPU credit usage count. You can see it was spiked here, like this is the spike. My credit usage was the most here, and this is how my credit balance just dropped slightly, you can see, and now it is again regaining. Okay, so I can regain my credit balance ultimately automatically by AWS over the time, and my credit usage was more here. My CPU utilization I can also monitor from here, like it was utilizing the most here at this point, and suddenly it was dropped, and now it is also regaining. Okay, so this is how I can check my CPU utilization, credit usage. So I hope this was much understandable to you. We will see elastic IPs. Okay, so let's start now. So whenever you start and then stop the EC2 instance, you will observe that its public IP, that public IP before ID changes. Okay, it just changes and it gives you different values whenever you start and stop the EC2 instance. And if you need to have a fixed public IP instance, address, then you require an elastic IP. Elastic IP is a service from AWS which just fix your IP address to the server whenever you are working at an instance. Next is an elastic IP is a public IP before you own until you don't delete it. Okay, until you don't disassociate or until you don't delete it, that IPv4 address will be sticked to your elastic to your instance. Okay, you can fix it to one instance at a time, and you can remap it across instances. You won't have to pay for elastic IP service if it is attached to a server. Suppose you are working and if it attached to a server, then you don't have to pay for that. But if you aren't attached to a server, then you will have to pay for that elastic IP to AWS. And this is a picture showing that how you can use elastic IP and how elastic IP is used. Because see, suppose you are a user and elastic IP just give you a fixed user IPv4 address, and using that IPv4 address you can connect to your instance again and again, and that will be logged like public subnet. Here it is, that will be logged actually, and that will be your own IPv4 address until you don't delete it. Next is how this can help. So with an elastic IP address, we can handle the failure of an instance or software by rapidly remapping the address to other instance in same account. Suppose you have two instances and you are working on an instance, and somehow it just fails. Okay, so that failure of an instance can cause trouble to you. So to handle that, this elastic IP address helps us a lot. Why? Because suppose your first instance is failed here, and now what you want that work to be switched on another instance. So your fixed public IP, this elastic IP, will help you. This will be remapped to another instance, which is instance 2 or instance 3, whatever name you have given to your instance. So it will be remapped to that instance, and that then you can continue your work there actually. So now you can only have 5 elastic IP in your account. Okay, but if you want to increase it, you can ask AWS for that. How you can avoid using elastic IP? So you can think of other alternatives that are available to you. You could use a random public IP and register a DNS name to it. That will charge a lot. Or you can use a load balancer with a static host. So this is all. Let's go to hands-on now. Next hands-on is, suppose this is your instance. You have made this instance. Okay, this is stop. Let's run it now. As I told you that whenever you will start and stop your instance, your public IPv4 address will be changed. Okay, so to fix that we use elastic IP. So this is our public IPv4 address. Let it be started. Okay, so this is my public IPv4 address, which is 54.253.137.94. okay, just remember it. I'll just stop my instance and then again restart it, and you will see that this public IPv4 address changes. Let's stop and restart it. This public IPv4 address is gone now. Now let me start it, run it again, and you will see that my address, public IPv4 address, will be changed now. And look, my IPv4 address is now 3.26.49.209. It is changed now. So how I can fix this public IPv4 address? I can use this elastic IP, which is there in the left side in network and security. The second one is elastic IPs. And now you can allocate one elastic IP address to yourself. Just allocate this. You don't have to change anything. So this is my allocated IPv4 address. Suppose I am just looking this 13.210.97.65. This is my allocated IPv4 address. If I name it here, let me name it like ELIP, elastic IP. Okay, I am just saving it with this name. Now what I'll do, I'll just associate this elastic IP address, which is present here in action, or you can see here. So in action, associate elastic IP address, I'll just click it, and I'll associate this elastic IP address to my instance. So I have associated this IP address with my instance which was running, and its IP address was something like 3.2. Which was in past. Okay, now it is changed. You can see it is changed now, and this public IPv4 address is now ELIP, that I have enabled, that I have created my elastic IP now. This is that public IPv4 address. What I have to do, I just have to connect and check whether it connects me to the EC2 instance or not. So let's click on this connect button and then just let us connect it now. And so I am successfully connected with my EC2 instance. I'll just write one command to check whether it is working or not. So yep, it is working fine. Now I have to stop and start the instance and check whether this IPv4 address is being changed or not. So if I'll stop, you will see that like private IPv4 address, it will also be fixed right now. Just see. I'm just stopping it. And yep, see, this public IPv4 address is here only and my instance state is stopped. In the previous case, when I had not created elastic IP and when I just stopped this instance in the past, what I just countered, and that was public IPv4 address was not there, it was just dash dash, and here I can see this public IPv4 address which is ELIP, which I have created in elastic IP address. Now I'll just connect or start my instance, which is instance state. I'll just start it and now it is being started, and you will see that my public IPv4 address will not be changed, it will be the same. Though we have stopped and started our instance, but still we can see that our public IPv4 address has not been changed yet. So this was the hands-on. Now to prevent the extra charges, you can just disassociate your elastic IP and then release that IP to just prevent that extra charges that will be given to you by AWS. So just disassociate with this elastic IP address now, because if you are not connected with the server, then AWS will charge you for elastic IP address service. So I have just released, and now you can see my instance will have a default IP address that is given by AWS. Look, this is the IP address. We will see CloudWatch metrics, how CloudWatch is attached to AWS, and we will see all the things here. Now AWS provided metrics, like AWS provides some metrics, and these are like basic monitoring metrics which are fetched at a 5-minute interval. Okay, AWS pushes them for you. Now detail monitoring, it is a bit paid, and metrics are fetched at an interval of 1 minute. Okay, next is it includes CPU, network, disk, and status check metrics. Just remember these four are very important to you for the exam point of view. Custom metrics, you can push them, these metrics you can push, and basic resolution is 1 minute resolution, and if you want a high resolution, then you can go to 1 second resolution also. It includes RAM application level metrics. Make sure that your IAM permission of the EC2 role is given correctly. Okay, next is CPU utilization plus credit usage slash balance. This is the first metrics that is provided to you by AWS. You can check your CPU utilization, your credit usage, and credit balance that is used for burst. Network in or network out, everything will be provided by AWS. Next is status check, it's instance status, or the check the EC2 VM, your virtual machine, whether it is working correctly or not. Next is system status, check your hardware in which your instance is running, whether it is running correctly or it has some problem. Next is disk read, write, and bytes operations are given to you by AWS. Important note that RAM status is not included in the AWS EC2 metrics. It is not there. Next, do some hands-on and check whether. So here is my instance that I have created. I have just opened this instance. I hope you know how to open it. If you don't, just go to this instance, your running instance, and just click on this view thing, okay, this link type thing, and just click it, that instance ID, and then you will be in your instance. Okay, now what you have to do, you just have to monitor. Okay, so you just have to click this monitoring button, and in this monitoring button you will see like these all things like CPU utilization, network in, network out bytes, network packets, CPU utilization, how much CPU is being utilized here, that is your CPU utilization. If your instance is running, it will show you. If you are working and if your instance has a load, then it will show you that CPU is being utilized here. And network in and network out bytes, network packets here, whether in how much network is coming into your EC2 instance and how much network is going outside from your EC2 instance. Packets transfer also will be shown here, network packets out or network packets in. Disk read bytes, disk read operation, all this will be 0. And why 0? Because we have an EBS backed instance, so that is why it will be 0. Credit usage and credit balance will be shown to you. You can also check it from here. If you want to add to dashboard, you can add some these two dashboards and you can have a good view of these. Like you can just create a dashboard of whatever name you want, so you can name anything like EC2 dashboard, and I have created. And now I'll be making a custom dashboard here. Like I'll be just given that what thing I want to give, so I can just do next here and I can check all the metrics here. Okay, what I have to do, I'll just delete this dashboard now. Okay, I can have a proper view from this EC2 dashboard. Now what I can do, I can also enable this manage detail monitoring. What is this detail monitoring? Now that I said AWS pushes your monitoring at every 5-minute intervals, but for if you want some detail monitoring, so AWS will push it for you at every 1 minute. If you have a heavy workload and if you want to be like in your budget, so what you will do, you will just pay for this detail monitoring and it will provide you the instance metrics at every 1 minute interval. By default it is 5 minutes, but then it will provide you at every 1 minute interval. This is your detail monitoring. You can just enable it and confirm it, but it will charge you a lot, so I am not gonna enable it right now because I don't have any work. So this was the thing, how you can see that CloudWatch is attached to AWS. We will see unified CloudWatch agents. So for virtual servers, EC2 instances or on-premises servers, these unified CloudWatch agents are there. They collect additional system level metrics such as RAM, process, use disk space, etc. They collect logs to send to collect CloudWatch logs like access logs or error logs, whatever the processes are being run in your like servers, virtual servers, all these are collected by these. No logs from inside your EC2 instance will be sent to CloudWatch logs without using an agent. So basically these CloudWatch agents send these logs from your EC2 instance inside your EC2 instance to the CloudWatch. Okay, they have a centralized configuration system using the SSM parameter store. But when you are using this, you have to make sure that IAM permissions are given correctly, and default namespaces for metrics collected by the unified CloudWatch agent is CW agent, and that can be configured and changed. This is the figure that shows you that how you can use your CloudWatch. You can send your metrics or you can check your metrics to CloudWatch using CloudWatch agents. This is CloudWatch and EC2 instance which is unified with CW agent. So basically these logs are being pushed there. Okay, and metrics are being pushed, and this is the server which is sending all the things to CloudWatch. Okay, server is also sending these to unified CW agent. With the help of unified CW agent, server is also sending metrics and logs to CloudWatch, and EC2 instance is also doing this. Okay, next is collect metrics like Procstat plugin. What is this? So Procstat plugin basically collect metrics and monitor system utilization of individual process. It supports both Linux and Windows servers. Example is, suppose the CPU is taking some amount of time in processing, so that process time, that metrics will be also like monitored by procstat plugin. Next is amount of memory the process is using. So basically whatever an individual process is doing, like time or memory, all these things will be collected, and you have to select which process to monitor by. So suppose PID file, name of process is identification number, which is PID actually. So name of the process, PID files they create, or either exe, like process name that match string you specify, regex, and pattern like command lines used to start the processes. All these things will be monitored by these. Metrics collected by procstat plugin begins with procstat prefix, like procstat CPU time, procstat CPU usage. So all the data and metrics which is being collected by procstat plugin will be having an name, will be having a procstat prefix, and this will show that these all data are being collected by procstat. Okay, this prefix shows you. So I hope this is clear to you. We will see that how we can make a CloudWatch agent. Okay, and we will just configure this CloudWatch agent for our access for our log files actually. And let us start by doing all these things. So first of all, what you have to do in AWS, you have to make a role, IAM role. You have to configure that. I have made for you actually. So I'll be just opening it like IAM. You have to search IAM and then you have to open your IAM from here. Just wait, and this in your IAM console you have to go to roles. Okay, just go to the roles, and then you will be making like create a role. Go to this create a role, and then on this AWS service, just your use case will be EC2. So select your EC2 here, then click on next. Like I am choosing this EC2, and then I'll be just clicking on this next. And what now? And now here you have to select for CloudWatch agent. Okay, and in this CloudWatch agent you have two policy, admin and server. Just click both the policy and just click on both the policies. Like I have just ticked the both like admin and server policies. And then I'll be pressing this next, and then you have to create a role here. Just add a meaningful name like Amazon CloudWatch agent, I'll be naming it. Okay, so you can name whatever meaningful name you want. Nice. And then you can work on it. So first of all, just create this Amazon EC2. I'll be just naming it Amazon EC2 role for CloudWatch. Okay, this is my name. And okay, what now? So in the next part I'll be just this is my description. These are my JSON files. If you will open this, you will see that JSON file is here. Your JSON file is actually, just wait, yeah, you can see all the things in your JSON file. In admin policy you have get parameter and put parameter both, so that is a better thing. Now I'll be just creating this policy. Okay, just create this policy, create this role from here, click here, and then you a role will be created of your name. I'll be just leaving this page because I have already created it for you, Amazon EC2 role for CloudWatch. And then I'll not be selecting it right now because I have to add it to to that EC2 instance. So for that I'll have to make an EC2 instance. I'll just cut this. Now we will select EC2, and this is my Elastic Compute Cloud EC2 instance, and I'll be launching an instance, and in that I'll be configuring, I'll be just adding this IAM policy. Okay, so let us launch this instance now. Let us name it like my CloudWatch, and that is better name. Okay, do one thing, you can select, like if you have this key pair stuff, you can just proceed without a key pair, that is all okay. In the security group you have to allow HTTP traffic from internet, because we will be making an HTML file and we will be running it on browser. So for that, allow internet and what CloudWatch will command how we can actually make a file, HTML file, and we can connect or see it in browser using our public IPv4 ID. And for that I have this instance. Now I'll be connecting to my instance. Let us connect it. So it isn't running right now. Let it be started. Yep, it is running now. Let us connect to it. And before connecting to it, let me do one thing. I'll be adding, like in this instance, what I have to do in actions and in security, you have to modify IAM role of this. You have to choose one IAM role, which is Amazon EC2 role for CloudWatch, and you have to update your IAM role for this. Now you can connect, and whatever configuration you will be doing, this IAM role is there. Okay, and access policy and your admin policy is there for CloudWatch agent. What next? So let us connect and write some basic commands. And what are those commands? Like I'll be just entering into my root mode. I'll be entering into a super user using sudo su. So yeah, I am a root user now. What I have to do, I have to install httpd service. So for that I will be writing yum install httpd service, and yep, it will ask yes, so why, and then it is now installed. And after it is installed, we will be doing some echo stuff, like echo hello world. What now? So I'll be creating a file, and just I'll be entering its information, where www/html/ my file name is index.html, and that is better. Enter, and yeah, that file is created. And what I can do now, I can just start this service using sudo systemctl, okay, and start httpd. I can also run one thing more, like enable. Using enable, I can restart this httpd service. So I can write enable also, no worries, and both the things works for me. Now as I have created this .html and into this IP, and as I have written this content, hello world, okay, so whenever I'll just copy and paste my public IP in my browser, I'll see that hello world here. You can see, just wait, you can see this hello world here. This hello world is here. This is my content for EC2. So that is a better thing. What now? Now I'll be configuring CloudWatch agent. Okay, so let us clear it now. For that, to configure your CloudWatch agent, it is a very tedious task. Actually, it is a complex task, and to make that simple, I have entered all the required commands. I have just created this file for you in this code, and this code basically shows you step by step configuration of your CloudWatch agent. What you have to do, you just have to copy this code and then paste sudo yum install Amazon CloudWatch agent, and yep, my Amazon CloudWatch agent will be installed now. I'll be just pressing yes, y, and yep, it is being installed. And once it is installed, we will be opening a wizard for configuration of Amazon EC2 CloudWatch agent, and we will be just configuring it. Okay, so this is complete. You can see this is complete message. This complete message is here, and make sure you give IAM roles permission correctly, and you are connecting your Amazon EC2 with your IAM role, and that is one thing you should keep in mind. Now run the wizard. To run the wizard, I have this sudo opt AWS Amazon CloudWatch agent. So I'll be just copying and pasting this command here. I'll paste this command here and just enter. Yep, it will show me some of the choices which I have to make to configure this. So I'll be just choosing some default values and I'll be entering wherever it is required. I'll be changing all those default values. Like on which OS are you planning to use the agent? So yes, it is my Linux agent. Next is EC2. I want to use EC2, so I'll be keeping it default. Next is which user are you planning? CW agent, no worries. Do you want to turn on stats daemon? Yes, of course. Which port? The default port. What is the collect interval for stats daemon? So if it is 10 second, I'll be keeping it default as 10 second. What is the aggregation interval for metrics collected by stats daemon? So yeah, it is what it is. I do not have to aggregate, so I'll be choosing default value. Do you want to monitor metrics? Of course, but if I would have chosen no, that would have been perfect. But yep, as I have just entered yes, so no worries. Do you want to monitor any host metrics? So yes. Do you want to monitor CPU metrics per core? Yes. Do you want to add EC2 dimensions? Why not? Do you want to aggregate EC2 dimensions? Of course. Would you like to collect metrics at high resolution? Yes. At every 60 seconds. Which default metrics configuration do you want? Basic. Are you satisfied with the above configuration? Actually, I am satisfied, so I'll be just choosing yes. And this is my JSON configuration, whatever I have chosen yet. So do you have any existing CloudWatch agent? So I don't have. Okay, so I'll be writing no, and that no is not actually supported. I'll be choosing 2 for that. Do you want to monitor any log files? So yes, I want to. Log file path, so I'll be giving path for my error files and log files. So for access log files, I'll be giving my var path like /var /log /httpd /access log. Okay, enter. Default choice access log. Log group class standard. Log stream instance id. I'll be keeping it for every 7 days, so I'll be choosing option 5. Do you want to specify any additional log files to monitor? Yes, I want. Log file path /var /log /httpd /error log. Okay, so this is one thing, and yep, I'll just enter it and my error log will also be added. Error log standard, all the things will be default. I'll be choosing 5 here. Default choice no, I don't have to add any additional log files now, so I'll be just choosing no. Do you want the CloudWatch agent to also retrieve X-ray traces? Okay. Do you have any existing X-ray daemon configuration to import for migration? No. Which UDP port do you want X-ray daemon to listen to? Same, default. Enter the maximum number of concurrent calls, default. Enter the AWS region to send. Okay, optional hai. So what we will do, we'll just click 0 here, and yep. Do you want to store the configuration in SSM parameter store? So whatever choices you have made, this is your JSON file which is created. Okay, current configuration of your choices are here as a JSON. Now do you want to store this configuration in SSM parameter store? Actually, I want to store, so I'll be choosing 1. And what parameters store name? So Amazon CloudWatch Linux is the perfect name for me, so I'll be choosing this. AP, and yep, AWS credential should be used to send JSON, so this ASIA one will be selected. That is actually okay. And yep, my Amazon CloudWatch Linux 2 has been created and it is successfully put on parameter store. So for that, I'll be checking my parameter store, and to check that, what I have to do, I have to open this parameter store, and in this parameter store I have one parameter which is CloudWatch Linux. Okay, you can visit your parameter store actually from your search tab, and in that search tab you have to enter AWS System Manager, and in that System Manager you will be locating your parameter store, and in that you have this one. And this is my configuration for parameter store. You can say this is my configuration, default configuration. And now what I have to do, I have to boot up this configuration in my EC2 instance. Okay, so to boot up this configuration, I have two choices. Either I'll be I have two options. Either I'll be just using this ssm1 command, in which I'll be adding this ssm, like the name of that parameter store, that JSON file, or I'll be adding the path of that. Okay, so either adding path, I'll be choosing this one, and I'll just go to my instance and I'll just paste it, and now I have to enter. And yep, configuration validation is succeeded, configuration validation second phase succeeded, everything is succeeded. So my CloudWatch agent is perfectly booted up here, and you can, whenever you will just update, you will refresh all these things, you will make changes in your file, everything will be stored in your log files, and you can check that log file in your like CloudWatch, and then in log groups you can check. Okay, in CloudWatch log groups, in log groups you can check access log and your error logs, that will be updated whenever you will update the things here. Okay, so this is how we collect metrics using CloudWatch agent. We send metrics using CloudWatch agent, and in those log files actually that process, individual processes are stored. So this is how I have to configure, we can configure our CloudWatch agent. So I hope this video was much understandable to you. This video was actually very simple. This contained some basic configurations.
So status checks are basically automated checks to identify hardware and software issues in AWS. System status checks, what are these? So we can see that system status checks basically monitors issues with AWS systems, which might be software, hardware issues on the physical host. That can be loss of system power and etc. It monitors personal health. It checks personal health dashboard for any scheduled critical maintenance by AWS to your instances host. Suppose if there is any personal health dashboard, and if it is scheduled for critical maintenance, and if your hardware fails, then it will just connect you to the other hardware if you start and stop and start the instance. Okay, so then it migrates to a new host, to a new hardware that I'll be showing you in a picture in a moment. Let's see the third case, instance status check. First is system status checks, and second is instance status checks. It basically checks the status of an instance, like how the software and network configuration of your instance is done. If there is any invalid network configuration or used up memory, then it will monitor that. And for that, the resolution is you can change the instance configuration, or you can reboot the instance. Here is the picture depicting the first case, that is system status checks. So how you can do that? Suppose if you stop and start your this thing, then what happens? Your hardware, suppose if your first hardware fails, then it will migrate you to another host, which is host 2. Okay, so suppose if your health dashboard has scheduled any critical maintenance for your instance host, suppose it is host 1, then it is failed, it will not be connected, then that will be migrated to your host 2. Next is status checks, CW metrics and recovery, CloudWatch metrics and recovery. Now, CloudWatch metrics is done on its status is basically updated on 1 minute interval, and that is status check field system, status check field instance, and status check field for both system and instances. Okay. Next is option one, CloudWatch alarm. So what is this CloudWatch alarm? So it recover EC2 instances with same public and private IP, EIP, that is basically elastic IP, and metadata and placement group. Okay, it just recovers your EC2 instance. If some instances fail, then it recovers. It notifies using SNS also, and option two is auto scaling group. So what is this auto scaling group? Basically, it sets your minimum, maximum, or desired one to recover an instance, but won't keep the same private and elastic IP. So like what is the benefit of using auto scaling group? So suppose if you are using auto scaling group, and if you have done automation very well, then your instance will be recovered very well. Okay, it might be recovered, but your private elastic IP will not be same, but you will get your IP at least, or your instance at least. Next is this is option one. Here you can see CloudWatch is monitoring EC2 instance logs, and if anything fails, it triggers it to CloudWatch alarm, and then it that CloudWatch alarm recovers your EC2 instance, and it might also send notification to Amazon SNS. This is auto scaling group. Suppose your instance fails, then it will launch another instance, but you will get another IP, different elastic IP, and your private IP won't be same anymore, but at least you will get your instance recovered. CloudWatch status alarm. Okay, so how does it works? We will see, and then we will see that how we can just enable that alarm and recover our instance, or see what it does. Okay, so for you, I have created an instance. So you have to launch an instance, and in that launched instance, what you have to do, I'll show you. I have configured it for you. So let us see the steps now. In instance ID, you have to click your instance ID, and in that you have to go to status and alarms. Okay, here is the status and alarms. You have to just go into that. And now in this, we have to create actions. In actions, we have to create status check alarms. Okay. And in this, what we will do, we will just create an instance status. Okay. In actions, we have to create status check alarm. And in this, we will create an alarm. Then we will write any of the existing topic you can write here, and then what you have to do, you have to enable this alarm action here. Suppose you will be enabling this alarm action, like just tick it, and then you can recover, reboot, stop, or terminate your instance, right? So suppose I want to recover my instance, then I'll just click on recover, then consecutive period, then I'll just keep it default, and then I'll just create this instance. So see, here is the create one. So I'll just click this button and my instance will be created. What instance? Like my alarms will be created. Sorry. Manage CloudWatch alarms will be created. Okay. So this will be created, and as this will be created, we have to see, we have to check this alarm whether it is created or not. Then we will just go to the service like CloudWatch. Okay, we have to write CloudWatch alarm. And here CloudWatch will be open. Just click on it. You have to click on it. Now this in alarms or all alarms, you can click anyone. So this all alarms, you have to click here. And in this all alarms, see, I have created an alarm. Okay, and its state is okay. By the way, you will see an alarm here. You have to click on it, and your status will be shown here, right? Then your events, your details for this alarm will be shown. Everything will be shown here. You can see the history of this also, that what this alarm has been doing. So I have just configured it at this time. State has been updated at this time. This the whenever you will create an alarm, CloudWatch alarm, this message will be there, insufficient data. So it takes some time to update itself from insufficient data to okay, and then you can just trigger it, trigger this alarm. You can just enable this alarm in your Cloud Shell. And how you can do that? You just have to write some basic commands, and for that you have to seek to Google or your browser, and you have to write set alarm state, okay, in AWS, and then CloudWatch agent, or you can write anything. CloudWatch set alarm state. You can write, and then the first documentation will be open, and in that you have to come to this, and you will see the synopsis. And to set alarm state, you have to enter your alarm name, then state value, and then state reason, that why do you want to just enable this alarm. And here I have entered everything, every sort of thing for you. Just watch it. I've already configured it for you. We'll just clear it, and then we will see. Okay, so this was our command. AWS, look, AWS CloudWatch, and then you have to write set alarm state like this. and then alarm name. Alarm name, I'll be copying it from here. Like suppose I had my alarm name. See, in the CloudWatch alarm, you will be having your alarm name here. You just have to copy it, right? Just copy it from here and then paste it using a right click button. Okay. So your this is your state name, your alarm name. This is your alarm name, set alarm state. And this is your set alarm value. Your alarm value should be alarm. Okay. Your state value should be alarm because some possible values are here. It is shown that the possible values can be okay, alarm, and insufficient data. So you have to show the value alarm. Okay. You have okay and insufficient data, but you will have to show it alarm here. So you will just enter state value as alarm, and then state reason will be testing recovery action. You can write any, you can give any reason for that, and then just press enter. And whenever you will press enter, right? Suppose I have pressed enter here, then what? Then I'll see that my alarm will be in alarm state. Okay, I'll just refresh it, and it is in alarm state. Okay, so that means your hardware is being changed. Uh, AWS is sending alarm that okay, there is some issue in hardware, and what now? So whenever your instance gets recovered, because I had chosen as a recover, okay, my state as recover alarm state. So what I want to recover my EC2 instance. Okay, so now what? Now AWS will just recover my instance, and when it is recovered, when it again becomes okay, so it will give me a message, or it will notify me through mail, my entered mail ID. It will just send me one mail that okay, your instance has been recovered and you can work on it now. So we will see EC2 hibernation. Okay, so basically we know that there are two options whenever we launch an EC2 instance, and those are stop and terminate instances option, right? We get the option, and we very oftenly stop an instance or terminate an instance. But there is also another option, you might have seen that, which is EC2 hibernate. So how we can work on that option and what is that option? Let us explore in this lecture. So basically termination, what is termination? Let us see. So basically termination is that your EBS volumes also set up is to be destroyed. Your EBS volumes will be destroyed while whenever you will terminate your EC2 instance. Next, stop. So basically, whenever you stop your instance, then the data on EBS, okay, like EBS volume actually, the data on the disk is kept intact in the later start. Whenever you stop the instance and start later, then again, that EBS is basically stored, and your work is basically stored, the data is stored, and it is kept intact. Whenever you will start it later on, your IB will be changed, but your work will not. Okay, on start, the following happens. What is the process? Let us see. First, start basically it gets the OS boots, and the EC2 user data scripts runs there in the backend. Now, whenever you start again and again, the following starts. Uh, in that EC2 user data doesn't actually runs again. The OS just boots up and the following starts, and then your application starts. Caches that are there in your instances gets warmed up, and that can take a while, okay, to start, right? Next is let us see what is EC2 hibernate. So introducing EC2 hibernate, the RAM state is preserved whenever you are hibernating an instance. Then your RAM state will be preserved. The instance boot is much faster. Also, the hood, the RAM state is written to a file in the root EBS volume, and the root EBS volume that should be encrypted whenever you are hibernating. That we will see in our hands-on, right? Use cases. So whenever we are having a long run process, then we can hibernate our EC2 instance, or the services that takes time to initialize. There we can use EC2 hibernation, right? This is the picture depicting EC2 hibernation. So this is basically hibernation. In hibernation, your EC2 instance doesn't actually shuts down. Okay, it is running in the background, but
but you have to provide a memory for that. We will also see that in our hands-on. So let us move to hands-on and let us see how does it works, right? So this is our AWS EC2 dashboard. So let us launch an instance and see how hibernation actually works. So suppose I name my instance, any name I can give, suppose dash dash I'm giving. AMI, I'll choose default Amazon Linux, okay. Instance type t2.micro, that is good. Key pair, I'll choose my default key pair, or I'll choose suppose my EC2 SSH or first instance key, whatever I want, I can choose. So I'll choose my EC2 SSH. These are basically security groups, and that is okay. I'll just keep it default. Now here in configure storage, what you have to do, you have to open this, and then you have to add a new volume if you want, right? Or you can go to advanced settings. Okay. So suppose I'm here in advanced settings. Next in EBS volumes, what you have to do, you have to just drop down this volume. You can see this volume is 1 AMI root 8 GIB. So 8 gigabytes memory is basically allocated to my instance. But this T2.micro, as you can see, it just uses 1 GB of memory. So here, whenever I'll be launching an instance, so here I am having 8 GB and my T2.micro instance is taking only 1 GB. So this allocated memory of 8 GB is enough to store my EC2 instance load or workload. So I don't have to worry for that. But yeah, if you are working with any other instance type, you should take care of this, that your EBS volume should have much like a memory to store your EC2 instance data, right? So in this volume, I have to do one thing. I have to encrypt that. As I said, that EBS should be encrypted. So I have encrypted it here using this encryption. Okay. Now what? Now in advanced details, we will see. Here we will see hibernation. So stop hibernate behavior. This is my hibernate behavior. I have to choose it. I have to enable it. Okay. I have to enable this hibernate behavior, and then I'll just launch my instance. All the settings I'll be keeping it default. I'll just simply launch my instance now. Okay, you can see my instance is successfully initiated now. What next? So I'll just open my instance and I'll connect to my instance. Okay, my instance is running here. Now what? So let me tell you one thing. Whenever you stop your instance, then what happens? If you terminate your instance, everything will be lost. But when you will stop your instance, your new API will be allocated to you, and your instance will actually be shut down. It will not be up. But when you are choosing instance state as hibernate, okay, so this hibernate instance, this state actually hibernates your instance. That means that your instance will be running on background, but it won't be taking that much CPU process. Okay, let us connect to our EC2 instance and see the next steps. So I don't have to do anything here. I just have to write uptime. That will see that from how many times this instance is up. So this is up from last 1 minute, as I have created it just now. So it is up from last 1 minute, right? I am one user, load average is 1.23. Okay. Now what I'll do, I'll just hibernate my instance. So you can see I'll choose it and instance state, and I am just hibernating it. See, whenever you are working with this instance, na, uh, this message might appear, fail to hibernate the instance. This is because your AWS might not have been just processed it yet. You can retry it, and again it Just refresh this page, and now you can retry it. Your instance state will now be hibernated. You can check it now. Okay, you can see this is successfully hibernated because AWS might not have been updated yet in the backend. So this might give you this red tick sometimes. So okay, uh, now what I have to do, I have to start this instance again, right? So you can say fail to start the instance. Why so? Because it hasn't been updated. So I'll just refresh it again. And after one refresh or two refresh, you will see that my instance will be started. If I will start it again, just check. It is successfully started. So what I wanted to say basically is that sometimes AWS might not have hibernated what you want. Okay. So just cut all these notification. Now, uh, as you see, my instance is running now. Just wait. Okay, as you can see, my instance is running now. And if I would have stopped it, it would have been restarted again with a new IP. Correct. And also, whenever I stop it, that uptime is not there. Uptime is again 0 minutes because it is a like it will behave like a new instance that is having a newer IP. But here, when I write uptime, so it will show me 3 minutes or 4 minutes. You can see this is up from last 3 minutes. That is because I hibernated it. Uh, and when I hibernated it, it was actually running in background, but this uptime is showing me this 3 minutes. If I would have stopped it or terminated it, if I would have terminated it, I would have lost my instance, and if I would have stopped it, then this uptime would have like 0 minutes or 1 minute. But it is running from last 3 minutes, and now I guess it is 4 minutes, right? So this is actually cool practical. You can see that we can just check our instance whether it is hibernated or not by writing uptime. So I hope that this was much clear to you and how we can work on hibernation and what is hibernation. So let's meet in our next lecture. Until then, thank you.